Okay, so this is a last topic of week 6, which is a molecular orbital theory. We call the MO. And this is a MO means you form the molecule. So we form the bond between two molecules. So there is a understanding about bond order, which is shown up here. What is a net bond order, which you will answer. And then between two atoms. And so you need to use a molecular orbital energy level diagram, and you should use it. And this compound we call the boron nitride, and this is compound that we are dealing with here. So this one comes up to I just up there I draw sketch a little periodic diagram of the second row, and the first one is hydrogen, and second one is helium, and then the third one lithium. And the fourth one is beryllium, Be, and the boron, and the carbon, nitrogen, oxygen, fluoride, and the neon, right? Okay, so we wrote that. And once you write it, you need to categorize them into kind of the two different kind of the atoms in the second one. And here I'm going to kind of divide it up. So here, okay, so up to here, those three we call heavy, okay, heavy atoms. Heavy atoms. So just such as O2, F2, Ne2, if they were to form the bond, and this is a kind of the one that we're talking about for molecular orbital, diatomic molecular orbital. So we are talking about actually diatomic MO. That's probably what we can describe using energy field level diagram. If you go something more complicated, it's hard to actually describe. So let me try the blue color. So anything with such as here, these three, such as B2, C2, N2, those diatomic molecule, we call this is a lighter atoms. Okay, so what's the consequences of that? Okay, so the MO, diatomic MO, molecular orbital diagram, for one, which is lighter atoms, such as forming B2, C2, N2, and their energy level diagram is, so first we are talking about two S's, so 2S form sigma and sigma star from 2s and 2s star, and then you from the 2p orbitals you are going to form pi orbital, sigma orbital, anti-pi, and anti-sigma from 2p. So this is a pi orbital, which is there are 2 degeneracy from 2p, and this is a sigma from 2p, and this is now pi star from 2p, and this is a sigma star from 2p. That's how the energy level looks like from the bottom to top. And then let me use a red color because I use a red for the heavier atom. So number 2, such as heavy atoms, such as diatomic O2 or diatomic F2. So this is F2. Diatomic neon 2, and those are the one. You can find out, let me try to highlight the one that is, because of the high atomic numbers, the energy levels are more symmetric here. Okay, so this is from the P, and then there is a usual sigma star from 2s and 2s. So from the energy level going up, and that will be now sigma 2p, and let me write up sigma 2p star. So you can see, do you see those two kind of matching pairs? And this is a more like a mirror images, pi 2p, pi star 2p. Okay, so that's how the energy levels looks different. And for heavier one, this is how they are kind of symmetric in this way. For the lighter one, they're kind of staggered in a way. It's not symmetric, but it's 2-1, 2-1 scenario. And then let's look at what is my problem, what's my system of interest. It's a Bn. So Bn is kind of related to the lighter atom, so I have to use those two. And how many valence electron are we discussing here now? As you can see, so this is essentially lighter atoms, and the B means you have 3, and you have an N, which is a 5. So total, you have 8 electron in the valence shell for MO orbital, right? So you have 8 electrons. So starting from the bottom, so I'm drawing the 8 electron in the here. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, 7. And 8. So I have used them so far and everything paired up. So this is a case for Bn, which is now all electrons are electron spins. Okay, electron spins are. Okay, that's what I mean. Are paired up. So therefore, there's this one is therefore diamagnetic. Okay. So this compound is diamagnetic. So with the molecule will be paramagnetic, but diamagnetic. The answer is diamagnetic. And the number, so that is an answer for the second one. The first one is using this one because it is a lighter element. That's not my choice, not the other way. Okay, this is the one on the right is for the heavy atom. The third one is what is called a bond order. So bond order is half of electron in bonding orbital, bonding MO, minus number of electron in anti-bonding MO. Okay, so how many electron do you see in the bonding? And then let me try to circle it up with green. So this is a bonding orbital. So you see 2, 4, 6. So that's a 6 electron in the bonding orbital. And what about the one? Let me try to use something like pink. So this is an anti-bonding, right? This is an anti-bonding, and there is only one orbital, 2 electrons. So 6 minus 2. So that means half of 4, that means 2. So the bond order is 2. Okay, so that's the case for these answers. Thank you for your attention.